All right, so with the literacy activity, there's 4 questions we have to answer. Okay, but we do have to go over, okay, the reading part first. Now, the importance or the reason we do this, okay, in Science 10, we do it in Physics 20 as well, is because scientific literacy is an important skill. Being able to read a scientific article, document, whatever, okay, and get what we need from it, okay, that's something that's going to be a very important skill for you, especially if you're going forward into science in like university or something like that. Okay, I know Mr. Dickey and myself sat down one day when we were trying to decide how we were going to cover this kind of stuff, and we both had the same problem when we were in university. When we studied, we ended up reading the same stuff like 4, 5, 6 times because we didn't read it properly. It's not that we didn't know how to read, but we didn't know how to read a scientific article or chapter or whatever to get what we needed. So what I would do, okay, and this took forever, was I would read through my textbook with 4 different colored highlighters. Okay, the first time through, I would read the whole thing, and by the time I was done, I had highlighted pretty much everything. Okay, because I was like, man, everything sounded really important. So it must have been super important, so I highlighted it, most of it. Okay, then I would go through a second time and I could kind of cut that in half. So I would use a different color. Okay, now the stuff that's in this color is even more important than everything that I had highlighted in the other color. Okay, third time through, different color, I highlighted even less. Fourth time through, even less. That was the stuff that was super important. Okay, and while when I went back to study, it was good to know this is the really important, this is the semi-important, this is the not so important, and this is the I highlighted everything because I'm stupid. Okay, stuff, right? That was how I did it. But that took forever because I was reading everything 4 times. Okay? That doesn't help my situation. So what we started looking at is there a way to refine this? Is there a way to find out what's important without having to read it 4 times? Right. So that's kind of what we're going to go over today is some ideas or skills that you can use to help you avoid what we had to do. All right. And not have to buy 4 highlighters, just 1. Okay. All right. So if I have a scientific article like this one, okay, on how reverse osmosis works, okay, I could just read through the thing and then guess what's important, but then I'm going to have my same situation as I had before, okay? If I know what I have to do with this stuff, with this information, will I be better focused on what I need from it? Okay, so one of the things that I discovered after about 2 years of doing way too much reading was that at the start of chapters, there's usually like a thing that tells you what's really important in the chapter. Okay, on all of my lessons, that's the key points at the start of the lesson. That's why they're there. Okay, those are the things that are really important. All right. Also, if there's questions to answer, when should I look at those? Before I read the article or after? Before. See, you guys are smarter than I am already. Okay, it took me 2 years of university to figure out that I should read the questions before I read the article. Right? Because if I read the questions first, am I going to have an idea of what things I need to look for? A much better idea. Okay, so in this activity, we got 4 questions we got to answer. So before we even read the stuff, we want to read the questions. So we know what kind of things we want to underline or highlight or whatever. Okay, and incidentally, you can highlight in Google Docs. Just okay, it's the tab up in the Google Doc where you can change the color or whatever. Okay, so we're gonna scroll kind of through this because the questions are at the end. Okay, so the questions I have to answer after reading this article, okay, the first one says, compare and contrast the membranes used in reverse osmosis with a cell membrane. Okay, how are they similar and how are they different? So after reading that question, what are some things I should be on the lookout for when I read this article? Right. Okay. I want to look out for things that talk about properties of the membranes. Maybe it'll tell me what they're made out of. Okay. I mean, if it says cell membranes are made of this stuff and reverse osmosis membranes are made of this, there's a difference. Okay. That can be one of the things I'm contrasting. They're made out of different materials. Okay. Or how they work. Okay. If one works a certain way and one works another way, then I want to contrast that as well. If there's something they have in common, okay, then I want to compare that and I want to say these are some things they have in common. So I need to be on the lookout for anything about what the material or what the membranes are made out of, and how those membranes perform their job, right? That's stuff I got to look for while I'm reading through it. Okay, second question is, what provides the force needed to move water across a membrane in regular osmosis? Okay, and we've talked about that. It has something to do with salt concentrations. Okay, and reverse osmosis. Now, reverse osmosis is an artificial process. Okay, it's not a naturally occurring process. It's an artificial process. So, okay, the forces that would cause these two things to happen are going to be different. So when I'm reading through the article, I should probably be on the lookout for anything that talks about forces. Okay, and then I'll have something to write down for that question. Question number 3 says, in a short paragraph, explain and justify if you think using reverse osmosis would be an acceptable way to conserve water in a place like Okotoks where water conservation is important. Okay? We know it's important in Okotoks because last year we got told we couldn't water our damn lawns. Okay? Which for a person like me who likes having green grass was really hard because I had to watch my grass die. Okay, so we are worried about conserving water. If we're conserving water, that means we're using more or less. Less. All right. So things I have to be on the lookout for as I read this article would be how much water gets used or wasted or recycled or whatever using reverse osmosis. Right? There's got to be something in this article that talks about how much water reverse osmosis would use or waste or conserve or whatever. Right? So I'm looking at this not in terms of whether I think reverse osmosis can clean the water. We know that's what it's for. Can it conserve water? Will it use less water than the system we currently use? Right? That's what we're looking for in terms of this one. So it's an if. We got to have a paragraph here that says if we think that's reasonable, and we should probably justify that. Right? So we'll say we think it's reasonable or we think it's not reasonable and use information from the article to explain why. All right, and then in number 4, it was mentioned in the article that reverse osmosis is used to ensure impurities can be removed from certain products like wine and syrup. Can you think of any reason why purists might disagree with the use of this process in the making of these products? Okay, if someone is a purist, what are they interested in? Purity, yeah, or doing something the way it's always been done. All right. For example, like in the process of making wine, you like take your shoes off and you step on the grapes and you squish all the juice out of them. Okay. And then you put that juice in big barrels with some yeast and some extra sugar maybe, and you allow it to ferment. Okay. Basically, you let it go rotten. Okay, and you let the yeast inside use up some of the sugar, and it produces alcohol. Okay, as a result of this process. Okay, and that's how you get wine from grape juice, right? So if you're using reverse osmosis on that process, you're probably taking out some of the stuff that would be in the grape juice, the result of people stomping on the grapes, stuff like that. If you're a purist, you would like the fact that it was done the original way with people's dirty feet and whatever else. I don't know, maybe that gives it flavor or texture. I don't know. Okay, but right, if you're a purist, you kind of want it done the old-fashioned way, okay, as opposed to some modern way that you think might take stuff out that's important for high-quality stuff. Okay, so we probably want to look in there somewhere in the article if it talks about that. We should probably stop and make a little highlight about, okay, yeah, there was a question about this, so I'm going to highlight some stuff here and then look at my answer. All right, everybody kind of following what we're looking for in the article now? Okay, as you read through the article, if there's any words you're not sure of, okay, like you're not sure of their definition or how they were used, just okay, change them to a different color, okay, or something, or just write it down. Actually, write it down. Write down any words you don't understand. We'll make kind of like a word wall afterwards, and I can explain what those words mean, because part of this is literacy, and that is that we understand what all of it is. Okay, and what I mean by literacy, guys, is like if I read at 99% efficiency, that still means that 1 out of every 100 words I don't understand. Okay, and if I don't understand that word, maybe I don't understand the sentence it's in, or the paragraph that sentence is in, and it starts to affect my ability to process and understand the entire article or book. Okay, if you imagine, like they showed us this one day at a PD day. they showed us like, I don't know, it was like The Lord of the Rings. It was a big thick book. Okay. And they said, all right, you read it 98% efficiency. Doesn't, I mean, and most people would say, wow, 98 is pretty good. And then the guy took the book and he tore out 2% of it. And it was like a section of pages like this thick. Okay. He said, so you didn't understand this much of this book. And it's like, wow, I used to think 98 was pretty good. Okay. And now I'm seeing how much of a book I didn't understand. Well, it's quite a bit. Okay. So if there's a word you don't get, make sure you ask and we'll go over them just to make sure everyone understands everything. Okay. So I'm going to give you a little bit of time to read the article. Then we'll do the word wall thing. Okay, go over any words we don't understand. There's a few that I'm going to go over anyway, and then you can get started on the questions. Again, the idea here, guys, is this gets done today. Okay, in class, submitted, end of class. Right? Okay, have at her. Okay, let's go over any, let's say, terms, vocabulary, etc. here that we might not understand. Are there any words that pop out at anybody that you'd like me to go over before I go over the ones I'm going to choose? Kayla? Equilibrium. Okay, so equilibrium, guys, means a state of balance. Okay, so in terms of osmosis, remember we said that it was trying to achieve a state of balance between the salt concentrations on both sides of the membranes. That state of balance is referred to as equilibrium. That means the same amount of water is going across in both directions. Okay, any other ones? Okay, so there's a few that I've got highlighted here that I just want to go over just in case anyone didn't understand what they meant. Okay, the first one is desalinization, okay, or desalination. Desalination just means to remove salt from salt water. Okay, obviously we can't drink salt water in its pure form or we'll dehydrate, so to desalinize something means to pull the salt out of it. Okay, and reverse osmosis is one of the processes that can take like ocean water and produce drinking water from. In fact, nuclear submarines will use this process to ensure they have a supply of fresh water. Okay. Unprecedented. Okay, unprecedented means that we've never seen anything like it before. Right, so the flooding we had in 2013 was unprecedented. We had never seen flooding like that. Okay, in this area before. Right. If torrential, okay, torrential means like a torrent, very fast moving, like incredibly large amounts of everything. So torrential just means lots and lots of it. Okay, semi-permeable membrane. Your cell membrane is a semi-permeable membrane. That is, some things can get through it and some things can't. If it was permeable, everything would be able to get through, right? Because it is semi-permeable or selectively permeable, only certain things can pass through the membrane. All right, osmotic pressure. Okay, this is one of the forces that you'll probably need to talk about in one of your questions, but osmotic pressure is what causes regular osmosis to occur. Having a salt imbalance creates an osmotic pressure that pushes water towards the salty water. Okay, so there's an osmotic pressure that gets set up if there's an inequality or a non-equilibrium of salt on both sides of a membrane. Okay, everyone follow me on that? So we talked about that when we first talked about osmosis. I showed you the different cells. I showed you this diagram as well. Okay, so if we're looking at this diagram here, in this first situation, there would be an osmotic pressure for water to move from the left-hand side towards the right-hand side. That's why it moves there. There is an osmotic pressure that forces it to go that way. Okay. All right, concentration refers to how much of something is dissolved in the water. So if I had 2 glasses of water and in one I had 1 tablespoon of sugar and the other I had like 5 tablespoons of sugar, one of them is more concentrated than the other. It's got more sugar dissolved in the water than the other. Okay, so concentrate means how much stuff is in that water. Okay, bars of pressure. Okay, bars are a unit. Okay, the units for pressure. So if you have 50 to 60 bars of pressure, you're pushing something in one direction with that much pressure. Okay, in the metric system, we actually use pascals for pressure. Bars is different. Okay. And then voila is French for there it is, or there you have it, okay, in case you didn't know that one. Skeletal fluorosis. Skeletal fluorosis is a bone condition that you can get if you are not getting proper minerals, okay, your bones will get weak, right? And they can sometimes even bend or break easily, okay? If you get like rickets, okay, rickets is a type of skeletal disorder, and you essentially get like bow-legged, okay, because your bones just start to bend, right? They're not strong enough to bear your weight all the time. Fluoridation means to put fluoride in the water. Okay, that was done for years and years and years, and never hurt anybody. But now there's a bunch of people who say we shouldn't do it. Same reasoning as people used like 60 years ago when they started doing it. Fluorine's in rat poison. You can't put that in the water. Yeah, fluorine's in lots of things, and it's perfectly harmless in most of them, including your water supply. Okay, it just helps with tooth health. Right? If you look at like my parents' generation, they didn't have fluoridated water, and their teeth were full of cavities and stuff. Okay, my generation, we had fluoridated water. I have one filling. I'm old and I have one filling. Okay, it's the only cavity I've ever had. So okay, it does make a difference, guys, to have fluoridation in the water. All right, I think that was it, right? Oh no, sorry. Impediment. Okay, if something is an impediment, it is impeding or resisting or being a barrier to or slowing something down. Okay, so anything that's an impediment is slowing something down or resisting it happening. Probably the place you've heard it would be if someone had a speech impediment. Okay, it means that they have something that interferes with their ability to speak. Okay, like stuttering, for example, is a speech impediment. Okay, it interferes with someone's ability to communicate smoothly. Right? And then these two organizations, WHO and UNICEF. Okay, WHO is the World Health Organization. That's what that stands for, World Health Organization. They're the people who are supposed to respond to like outbreaks of disease and contamination of water supplies and things like that that could affect the health of people in those areas. Okay, and UNICEF is the United Nations International Children's Emergency Fund. Okay, it's money for children. Right. Back when I was a kid, you used to go around with these little orange boxes and collect pennies and stuff for UNICEF, and then they would total it all up and send it over to children in impoverished countries that needed clean water, clothing, stuff like that. So that's what UNICEF is. Okay, they essentially just help out villages and places where there's not a lot of money to be healthier. Okay. All right, so hopefully that helps you. Okay, in terms of the answers for these guys, looking for like a paragraph answer, okay, for each one. I'm not looking for yes or no, okay? You can have yes or no in that paragraph somewhere, but you got to have some explanation there, okay? We're looking for thorough answers here. This is going to get marked. It's going to get put in your grades, okay? So make sure you do a good job of it, all right? Any other questions? Okay.